Example 3. Highway chase. A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.9 miles north of the intersection and the car is 1.2 miles east, the police determined with radar that the distance between them and the car is increasing at 23 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? Step 1. Picture and variables. Let x equal the position of the car at time t. Let y equal the position of the cruiser at time t. Let s equal the distance between the car and the cruiser at time t. Step 2. Numerical information. At the instant in question, x equals 1.2 miles, y equals 0.9 miles, dy over dt equals negative 60 miles per hour, and ds over dt equals 23 miles per hour. Step 3. Find dx dt. Step 4. How are the variables related? S squared equals x squared plus y squared, or s equals the square root of x squared plus y squared. Step 5. Differentiate with respect to t. 2s ds dt equals 2x dx dt plus 2y dy dt. Therefore, ds over ds dt equals 1 over s times x dx dt plus y dy dt equals 1 over the square root of x squared plus y squared times x dx dt plus y dy dt. Step 6. Place in all numbers. 23 equals 1 over the square root of 1.2 squared plus 0.9 squared times 1.2 dx dt plus 0.9 times negative 60. Therefore, dx dt equals 23 times the square root of 1.2 squared plus 0.9 squared plus 0.6 times 60 over 1.2 equals 58.75 miles per hour. Example 4. Filling a conical tank. Water runs into a conical tank at the rate of 8 feet per minute. The tank stands point down and has a height of 12 feet and a base radius of 6 feet. How fast is the water level rising when the water is 5 feet deep? Step 1. Picture and variables. Let V equal volume feet cubed of the water in the tank at time t. Let x equal the radius in feet of the surface of the water at time t, and let y equal the depth in feet of water in the tank at time t. Step 2. Y equals 5 feet, and dv over dt equals 8 feet cubed per minute. Step 3. Find dy dt. Step 4. Volume equals 1/3 pi x squared times y. And because we know x over y equals 6 over 12, therefore x equals y over 2 in all instances. So we must plug in y over 2 for all places that we see x. So volume equals 1/3 pi times y over 2 squared y, which is pi over 12 y cubed. Step 5. Differentiate with respect to t. dv dt equals pi over 12 times 3y squared dy dt, which equals pi over 4 y squared dy dt. Step 6. Plug in numbers. 8 equals pi over 4 times 5 squared dy dt. Therefore, dy dt, dv dt equals 0.41 feet meters per minute.